Jim wants to have $30,000 available in 3 years in order to buy a car. And he's found this certificate of deposit, a CD, that pays 5.2% interest, and it compounds monthly. So I'm going to just put a P/Y monthly there. And we want to know how much does he need to invest now in order to have that money. So we're assuming here that he's doing a one-time payment. So we want to know how much does he have to invest in order to end up with $30,000. He has 5.25% interest and 3 years times 12 or 36. And so I'm going to go over here to my TVM solver, start plugging in numbers. 5.25 is my interest rate. We want to know what the present value is be. We don't have regular payments. He's going to wind up with $30,000 in the account, and it compounds monthly. Solve for PV. So he would need to deposit $25,637.11. Well, most of us don't have that kind of money lying around. Might as well just buy the car. So uh, Jim also doesn't have that much money lying around. Instead, he decides to deposit money every month, hoping it's a little easier. So how much money would he have to deposit each month in order to end up with the same amount? So the reality is we're going to keep almost everything the same. The only thing we're going to change here is our PV and our payment amount. Our PV is now going to be 0, and we are now looking what our regular payment would need to be. So I'm going to go in here and I'm going to clear out PV and put 0. And I now am curious, what would my payment amount have to be for my monthly payment? And I find out that Jim here would need to pay $771.25 each month in order to end up with $30,000. And in the long run, he might end up depositing more than 25,000, but depositing, it's maybe easier for him to just save a little bit at a time. Okay, next problem, clear out our TVM solver. We put in $200 per month into an investment that earns an interest rate of 6.5%. How much money will you have when you retire in 45 years? So it's monthly, so 12 times 45. Interest rate is 6.5. We don't have a lump sum. Instead, we're paying $200 a month. We want to know how much money we'll have, and it's 12 payments per year. So I'm just sort of going to go through 12 times 45. And I love problems like this because it's a good explanation of why you want to start saving early. Because you're going to see 45 years worth of savings. You make some money. Okay, go back to future value, solve for future value. And drum roll, please. You have $645,700.35. Well, we want to know what the net gain was. So we do need to know how much we paid. So that would be what we'd find out by doing 12 times 45 times 200. And you would find that you put in $108,000. So that's how much got invested. And so take the money that you ended with in the account, subtract the amount we invested, and we find that you gained 537,700. Oops, I'm going to make that a little neater. Sorry. $537,700.35. Now, here's a question we haven't answered yet. We have been asked what percentage of the total money earned was from interest versus money you put in. So we would take that $537, $7,000, and we would divide it by the total amount in the account at the end. Part divided by whole, and I'm sorry, my handwriting is getting a little sloppy. And we want to turn this into a percent. If we just divide the numbers, we get a decimal, 0.833. So we would times that by 100, and we would find out 83.3% of the money in the account was earned from interest. Just a little neat, interesting fact. This comes up more into play when we look at loans, but I thought, oh, let's practice it a little now. All right, your dream is to purchase a small franchise that requires an initial investment of $75,000, and you want to open it in 5 years. You're looking at an account that has an APR of 33.7 compounded monthly. What would your monthly payments have to be in order to reach this goal in 5 years? So we have 5 times 12 because it's monthly. Interest rate of 3.7, no present value. We don't know what our payment amount is, but we want to end up with $75,000, and we are doing 12 payments per year. Let's clear out our TVM. So 5 times 12, 3.7, 0, 75,000, 12, solve. You actually have to deposit quite a bit. You got to deposit $1,139.86 per month. Now, instead of making a monthly payment, you'd like to just make one giant lump sum payment upfront. So what would my lump sum payment have to be in order to get that same goal? So basically, we're going to do similar to what we did on the last problem, or not last problem, but like 2 problems ago up here on number 7. We're going to just change around these values right here. We're going to now be looking for our present value, and our payment amount will be 0. So we're going to clear out our payment amount. So this is the case where I don't clear out my entire time value money calculator, just the values I need to clear out. And I see that I would just need to make a lump sum payment of just a lump sum payment of $62,350.57. And you might be going, that's a lot of money. It is. But you would save some money by doing it this way. So let's talk about what you'd save. So the question becomes, on the lump sum, you would deposit that $62,000. So how much did you deposit with the regular monthly payment? So remember, to figure out the amount you invested, you take your payment amount and you would times it by the number of payments. And we had 60 of those. And you would find out that you would put in $68,391.60. So if we want to know how much we save, we're going to take, our regular payment and we're going to subtract our lump sum payment from that. I'm going to subtract, and you'll find out that you save, this is our lump sum payment. How much did we save? $6,041.03. So $6,000 by doing a lump sum versus a regular monthly payment. It's not nothing, but it's not necessarily, not everyone can afford to just stick $62,000 into a bank account in one sitting. So maybe that $1,000 is more reasonable. All right, we're going to do one more problem in this video. I know it's on the next page. And this one, we're asked to sort of compare 2 investment accounts. So one involves an APR and one involves an APY. So a little discussion about the difference between an APR and an APY. An APR does not take compounding into effect versus an APY is like after all the compounding, it's sort of like its yearly growth rate. It's the yearly growth rate, no compounding at all. It just compounds once a year and that's your percent. So that's sort of what you need to think about it as. So it's like the APR compounds daily. Well, this is sort of like a yearly compounded. And then we can compare them. So so Jose here, he's going to invest $15,000. And so I can use my TVM solver for this. So it's really like let's just look at what you have in a year. So his compounds daily. So that's 365 times in 1 year. It has 5.6% interest, and he put in $1,500. And it's then 365 times throughout the year. And I want to know what the future value would be. So in 1 year, Jose here is going to have $1,586.39 in his account. Okay. Now, if I compare that to Maria's APY is like you are only compounding once per year. It's a yearly thing, which means my number now is down to 1, and it's a slightly higher rate. And so what would her future value be? Well, her future value in 1 year would be $1,584.75. So just looking at that, I can see that at the end of year 1, Jose has more money than Maria. Now I could keep doing this, okay, well, what would she have in 2 years? And so in 2 years, she would have, around $16,074.29. And I could compare that to Jose to see, are we still doing better? 2 times 365, solve. And this time he has, $77. So he's continuing to have more money. So in the end, which account is better? Well, Jose's is option 1. So has a better account because earning more money each year. And it's going to keep being more and more and more. And there are other ways to do this problem. I could have figured out what Jose's annual growth rate is. That was another option. Personally, I think this works fine. I don't need the annual growth rate. I just sort of like comparing the hard numbers when sort of looking at the two investments. It's important to keep in mind the difference between APR and APYs. Bank accounts are normally going to give you APY values. When you look at investments, they've already taken the compounding into effect, and you have to read the fine print to find the APRs. So it's a little bit of just, I wanted you to be comfortable with the language, and we'll sort of work more with that as we sort of continue in our finance unit.